Hi everybody, welcome to the section 2.5 video. In this section, we're going to be discussing a new type of differential equation called the Bernoulli equation. So, our learning objectives for this section are going to be define what a Bernoulli equation is and its key features. We're going to analyze the method to solving a Bernoulli equation. And then, of course, we're going to solve a couple Bernoulli equations and then check out an initial value problem. So let's go ahead and get acquainted with what a Bernoulli equation is. So, given a differential equation, there are some times where we need to transform the differential equation into another differential equation in order to solve it. And one of these transformations can be done through the method of substitution. And so in this section, we're going to discover one method for substitution to solving a Bernoulli equation. So relate this to integration where we take a challenging integral that we can't solve and we use the method of substitution to change it into an easier integral to solve. Well, this is a similar case where we're taking a very difficult differential equation using substitution to make it an easier differential equation to solve. And we can do that with the Bernoulli's equation. And so we'll say relates to U substitution for integration. Okay, so it's a similar concept. So let's go ahead and define what Bernoulli's equation is. So Bernoulli's equation is a differential equation of the form dy over dx plus p of x, some function of x, times y equals q of x, some function of x, but now we're adding a different component where it's y to the n. So here, this is y to some power n. Okay? And any differential equation of this form is a Bernoulli equation. So this looks similar to a linear equation that we previously learned, except there's another component to it. It's that y raised to the n, some y raised to the power. Okay, so our goal is always to solve a differential equation that looks like this form. Okay, we're going to learn a method to do that. But let's go ahead and identify some key features so that we can distinct between linear and Bernoulli and even separable. Okay, so let's see. If the power of the n is 0 or the power of n is 1, then that equation is linear. Okay. There are two functions of x, p of x and q of x, so that's similar to a linear equation. Y appears in the first power that when that's attached to that p of x function, and the nth power when it's attached to that q of x function. So similar to a linear equation, our derivative dy over dx is naked. Nothing can multiply it. It has to be naked by itself. And a Bernoulli equation draws back to the method of solving a linear equation, meaning getting into standard form, finding an integrating factor. Okay. Getting an integrating factor, the same type of process. And, we're dealing with a substitution method. And one thing we're going to utilize here is a substitution of this standard u equals y to the 1 minus n. So we're going to utilize a couple of these components when we start trying problems out. So let's go ahead and see like a method to solving this Bernoulli equation in step-by-step fashion. So there's always a step 0 to these, much like with a linear equation, in that we're going to put this Bernoulli equation into standard form. So we want it to match from up above, dy over dx plus p of x times y equals q of x times y to the n. So we want to put our equation into the standard form. And then we're going to do some substitution. So we let u, like we just mentioned, equal y to the 1 minus n. That n is coming from that power of n, this power right here. And we solve for y and the derivative dy over dx. And then we get into our substitution. We substitute these terms u and x. We substituted our differential equation is going to be in terms of u and x. And so then we utilize our linear equation that we previously learned and solve with an integrating factor, that mu of x. And then we substitute back in y at the end. So when you're having a little trouble with these problems, you're forgetting the step-by-steps. Hopefully these methods and can help you figure out the next step to take and put us in the right direction. So we'll go ahead and solve a couple of these in the next couple of videos, but I just want to introduce us in this video, get an idea of what we're going to be working with. So that's it for this video, and I'll see you in the next one. Okay, take care.